lithium-ion batteries will be needed for portable electronics, for instance. At least some of the chemistries there, since they are the highest energy density. But when you have other aspects where price is important, where power is important, or where safety is important, then sodium-ion batteries is often better alternatives. One of the elements that has been perhaps most interest is sodium, but since it's so similar to lithium, and since there are 1,000 times more reserves of sodium than lithium, and that is also reflected in the price. Lithium carbonates cost 30 times more than sodium carbonates. So it's for sure great incentives to do research about that and find sodium-ion batteries as an alternative for lithium-ion batteries. There have been a lot of research. There may be the most prominent researchers, Nobel Prize winner Professor Goodenough, released the article 5-6 years ago about one sodium-ion battery chemistry that is called Prussian white in a research language. At my company, we have named that FENAC. FENAC has as a cathode material. The cathode is the part of the battery that decides most of the features for the batteries, most critical part of the battery, more or less. And this FENAC contains only one metal, and that is iron. The original sources for the other elements in FENAC are air, and in seawater, and in forest. When there were 3 researchers from Uppsala University here inspired by this article, looking into this battery chemistry of FENAC, they saw there were only one missing link to make this commercial, and that was that it was very expensive to synthesize this cathode material. The method that Professor Goodenough used needed a lot of heat and a lot of pressure. So it works fine to do research about it, but to make commercial business about it was not viable. Those Uppsala University researchers found a new way of synthesizing this cathode material at very low temperature and no pressure. Using raw material that is very cheap, make it a very competitive cathode material. And it was kind of like locking up the last issue, making a competitive sodium-ion battery. For this battery is for sure one of several battery chemistries that will exist on the market. There are still lithium-ion batteries will be needed for portable electronics, for instance. At least some of the chemistries there, since they are the highest energy density. But when you have other aspects where price is important, where power is important, or where safety is important, then sodium-ion batteries is often better alternatives. So I would say that sodium-ion battery generally will be the dominant technology on stationary storage. For portable electronics, it will also in the future be lithium-ion batteries that will dominate that sector. While for electric vehicles that we speak about today, you will have a mix of sodium-ion batteries and lithium-ion batteries.